Hello everybody, how are you? How are you doing? It's Murad Sultan Zwidi with you again. So the third week we saw and we learned, let's say, a topic that deals with curved graphs, the curve of quadratic equation of, let's say, equation of the form y equal k over x when k is negative, k is positive, and so on. We'll see that it's a graph. Okay, our school is Samahan Bilingual School, Department of Math, Curved Grphs. Okay, grade 10, third week, 21st, 23rd March 2021, semester 2, of course. The topic is dealing with curved graphics. Okay, we will see the parabola and hyperbola, and your math teacher is Murad Sultan Zwidi. Okay, now I will give you time to at least to prepare some papers in order to start make some notes and take a close look at this lecture that will help you and will, let's say, may answer to your questions that you might have questioned. Okay, so we start, my learners. A graph quadratic function. The function, in fact, describing the height of the rocket is an example of a quadratic function. A quadratic, the definition of a quadratic function can be written in the form of y equal ax squared plus bx plus c, where a is different to 0 or is not equal to 0. Okay, this form of the quadratic function is called the standard form. Note that this polynomial has in fact degree 2 and the exponent are positive. Okay, the graph is of this quadratic equation or function is called parabola. It's called what? A parabola. Okay, clear? Now we move to key concepts, and the title is quadratic function. Also, we are in the same topic on the same lessons. What's the meaning of quadratic, let's say, function, and how can be written? So a quadratic function can be described by an equation of the form y equal ax squared plus bx plus c, where a is not equal to 0. And the models or the graphs of this kind of equation should be, let's say, a valley, a positive, or a hill. Or in other words, the graph here, look at the first graph. The graph in fact is a parabola, but it opens upwards, means that it's a valley. And for the second example, you can see that the graph, let's say, is opens downwards and it's called a hill. Okay, and this point for the upwards, let's say for the parabola that is open upwards, this point, it's in the third quadrant, it's called a vertex or turning point. Okay, this one I mean. Okay, then okay, then what else? So we told that this is the point where the curve, let's say, where the curve change direction. Okay, and the second one is open downwards, so it's a hill. And you can see that this is, for example, this is the axis of symmetry that divide the parabola into two symmetrical halves. Okay, so in order to graph or to sketch a quadratic equation, just find the y-intercept and the x-intercepts when the curve cuts the y-axis and when the curve cuts the x-axis, and so on. And then draw the axis of symmetry and draw or plot the point where the curve will change direction. Okay, we'll move to the second one. Here we have, let's say, graphs opens upwards. Okay, graphs opens upwards. You can see that an example. Use the table of values to graph y equal to x squared minus 4x minus 5. First of all, before completing this table of value, this table is already refilled, and you, my learners, you will try to construct a table like that and make the value of x is negative 2, then minus 1, then 0, then 1, then 2, then 3, then 4. Okay, and you are let's say asked to find the value of y when x equal minus 2, to find the value of y when x equal minus 1 using the quadratic equation, and to find the value of y when x equals 0, means the y-intercept, and to find, let's say, the value of y when x equal 1, which is here, which is, let's say, yes, okay, then the value of x1, x equal 2, 3 and 4. Okay, so before starting, you can see the coefficient of this coefficient of what? This coefficient 2 is positive. So the graph of the equation, which is called parabola, will opens upwards. Okay, and you should find also the axis of symmetry that cuts the parabola into two symmetrical halves. Okay, so just application. When x equal minus 2, it will be 2 multiplied by minus 2 squared. It will be 8 minus 4 multiplied by minus 2. It will be 16. 16 minus 5 gives 11. Okay, then when x equal minus 1, so 2 multiplied by minus 1 squared, it will be 2 multiplied by 1, it will be 2. Then minus 4 multiplied by minus 1, it will be 4. 2 plus 4, 6, minus 5 gives 1. Then when x equals 0, this is the y-intercept. Okay, it will be negative 5. When x equal 1, just substitute in this equation x equal 1, it will be 2. 1 squared, it will be 2, minus 4 multiplied by 1, it will be minus 4. So minus 2 minus 5 gives minus 7, and so on. This question, x equal 2, 3 and 4 is gonna be for you, and you will check the answer, and the y value should be negative 5 for x equal 2, 1 when x equal 3, 11 when x equal 4. Now, as we have, let's say, the we refill or we complete this table of values for y when x equal minus 2, minus 1, 0, 1, 2, 3, 4. We'll try to plot this point, then join or connect this point together to and to draw, let's say, try to connect them with a smooth curve. So let's do the first one. When x equal minus 2, y equal 11. X equal minus 2, y equal 11. This is 11. Okay, when x equal minus 1, y equal 1. Minus 1, this is minus 1, this is 1. Okay, when x equal 0, this is the y-intercept, means the point of coordinates 0, negative 1. Let's say cuts the y-axis, because the curve of this parabola cuts the y-axis at this point. It's called the y-intercept. Okay, then the vertex, it will be, let's say, 1, negative 7. This is Malern's 0, 1, this is 1, and this is negative 7. This is the vertex of your parabola, where the curve change direction. Okay, it comes from here, the curve is going to slope down. Okay, and at this point will change direction, will be going or slope upwards. Okay, and this just now make connection between these points. You will, let's say, get a parabola graph like that, and you should, let's say, label your parabola like y equal to x minus 2x squared minus 4x minus 5. Clear? Okay, the second question, consider now the standard for y equal ax squared plus bx plus c. And note that the value of a in example number 1 is positive, and the curve opens upwards. Here, this one is opens upwards, or the curve, it's seems like to be said as or read as a valley. Okay, V-A-L-L-E-Y. Then in this example we see the here the point here, it's the vertex, the turning point, but in fact also it's called a minimum. Why? Because the coefficient 2 is positive, or the x squared term is positive, so your graph should be like that, and that point, which is called the vertex turning point, it's called a minimum, has a minimum at which ordered pair of numbers 1, negative 7. Clear? Okay, now we have, let's say, we told that note the value of a in example 1 is positive, and the curve opens upwards, so the lowest point or the minimum point of the graph is located at point negative 1, negative 7. Now we'll see another example when the coefficient or x squared term is negative. For example, here a is negative 1, b is 4, we'll c is negative 1. We'll see if this one will be open upwards or downwards. It's clear that will be open downwards, because the x square terms is negative here. Okay, so then we can see that the value of x is -1, -1, then 0, 1, 2, 3, 4, 5, and you will get pause. We'll get, let's say, some rest. Now we'll take some rest for 2 minutes to start find the value of -1, the value of y when x equal -1, then the value of y when x equal 0, then the value of y when x equal 1, the value of y when x equal 2, the value of y when x equal 3, and the value of y when x equal 4, and so on. In order to answer this question and to refill, let's say, to refill this one, my learners, okay, to refill this one, you will just need what? You will just need, let's say, yes, you will just need, let's say, the value of y. Okay, here the value of y when x equal -1, it will be -1, -4, -5, -1, it will be 6. Okay, and this one minus it will be -6, and this is -6. Then when x equals 0, 0 squared is 0, plus 4 by 0 is 0, -1, it will be -1. Then when x equal 1, so -1 squared is -1, plus 4 by 1 is 4, -1 plus 4, 3, -1, it will be 2. When x equal, it will be 2. When x equal 1, the answer, the value of y, it should be 2. Then when x equal 2, -2 squared will be -4, plus 8, it will be 4, -1, it will be 3. Okay, for the second one, we have when x equal 3, -3 squared is -9, plus 12, it will be 3, -1, it will be 2. When x equal 3, the value of y is 2. When x equal 4, it will be -4 squared plus 16, because 4 by 4 16, -16 plus 16 is 0, so it remains only the -1 y, because okay, so -1. When x equal 5, -5 squared will be -25 plus 20, because 4 by 5 20, it will be -5, -1, it will be -6. Clear? Okay, now we will erase this. Now the curve, we said that the curve should be like that. It's open downwards. Why? Simply because the equation is -x squared plus 4x minus 1. To plot this point, just keep, let's say, forward for each ordered pair of numbers, -x, y, -1, -6. What is -1? This is the axis of y-axis. This is the x-axis. This is, my learners, it will be 0. This is when x equal -1, y equal -6. This is x is -1, this is, and this is y is -6, this point. Then when x equals 0, y equal -1. When x equals 0, the y equal -1. Why? Because this is the y-intercept. This one is called the y-intercept. Clear? And when x equal, let's say, 1, y equal 2, like that. When x equal 2, it will be 3. When x equal 2, it will be 3. And this point, it's called what? It's called this one, it's called the vertex, the turning point. Clear? I wish that it was clear. This one, we told 3, 1, 2, 3, 3, 2, 3, 2, this one. This one, it's called what? The turning point. Turning point. Okay, turning point, which is the vertex of coordinates. Okay, is labeled is v, in fact, of coordinates, what here, of coordinates 3, 2. Okay, and you can see the axis of symmetry. The axis of symmetry here, my learners, will be what? Axis of symmetry is what, my learners? Is capital X equal 2. Okay, equal 2. Okay, if you want to use the formula, just make that like that, my learners. just make the axis of symmetry will be equal, we told, in fact it will be capital X equal minus b divided by 2a. Okay, so minus b is what? Minus b, there is a negative sign, it will be minus. B is 4 minus 4 divided by 2 multiplied by minus 1, it will be minus 2, so should be equal to 2. This is the axis of symmetry. Clear? Okay, I wish that it was clear for you. 36, it's not enough. 32, maybe we accept 32. Okay, this is the turning point. Okay, for example here, if we would like let's say to find the x-intercept, if you would like to find the x-intercept, okay, if you would like to find the x-intercept here, my learners, I'll just keep this there. Okay, x-intercept, it's very easy. We will make y equal minus x squared is what? X squared, symbols, move to equations, is x squared. Now I need another conception, okay, I need another, this one, yes. So x squared, we told minus x squared, okay, plus what? Plus 4x minus 1. Minus 1 should be equal to 0. Okay, and this is the when you are going to find let's say the x-intercept, you will try to work out the roots of this equation. Okay, so we'll make like that. You will make this one, it will be equal to, you will use the method of completing the square if you want, or you will just using the quadratic formula. It will be 4 squared. It will be 4 squared means 16. Okay, minus minus, it will be positive, minus 4 gives 12. So the square root of delta here, it will be to the square root of 3. So the first root is negative 4 plus 2 the square root of 3 divided by negative 2, or negative 4 minus the 2 the square root of 3 divided by negative 2a, which is negative 2, and you will got your answer. Okay, so we continue. We told that, note that the value of a in example 2 is negative and the curve opens downwards the highest point, or it's called the maximum. Here this point, my learners, 3 2, this one, when x equal 3 y equal 2, it's called a minimum. Okay, or the graph has a maximum at this point because the curve is opens downwards. Of the graph is located at 2 3. The maximum or minimum point of a parabola is called a vertex. At least now you got the idea, my learners. Okay, I'll just, maybe this one I need this one there. Now move to the second part. Here key concepts: equation of axis of symmetry of parabola. Here in words, the equation of the axis of symmetry for the graph of y equal ax squared plus bx plus c is okay, where a is different to 0, so it will be x equal negative b over 2a. This is the curve, you see this one, this is the parabola, and what is, let's say, drawn in dashed line, in pink dashed line, is called the axis of symmetry, which is equal to negative b divided by 2a. If you can't use the method of completing the square to find the axis of symmetry and the turning point, it's better also to apply or to substitute the value of b and a in the axis of symmetry to find the axis of symmetry that cuts or divide the parabola into two symmetrical halves. Okay, and this one is the point. Here the curve is open upwards, so this point is the vertex or turning point. Also it's called a minimum, so the curve has a minimum at the point x and y. X is the axis of symmetry, and y is let's say when x is negative b over 2a, just substitution, you'll find the value of the discriminant. Okay, now my learners, you can determine information about parabola from this equation, vertex and axis of symmetry. So you saw before the mean of vertex, turning point, it comes the curve will has yes, a minimum point or maximum point according to the coefficient of x squared, or according to the sign of a, or according to the x squared term signs. If it is positive, so it's a minimum. If it is negative, is a maximum, and so on. So consider the graph of y equal negative 3x squared minus 6x plus 4. You from the beginning, a is negative 3, b is negative 6, 4 is c. Write the equation of the axis of symmetry, just substitution. In y, in my equation, this one, the quadratic equation, you will substitute x equal what? X equal x equal negative b divided by 2a, which is equation for the axis of symmetry of parabola. You will substitute, it will be minus 6 divided by 2 multiplied by minus 3. Why? Because a is minus 3. Okay, it will be minus 1. The axis of symmetry of this equation is minus 1, where a is negative 3, b is negative 6. Now the equation of axis of symmetry is written as that, x or big X equal negative 1. Clear? Now we move to find the vertex. To find the vertex, just substitute x equal negative 1 in y. Means y equal negative 3 multiplied between parentheses negative 1 squared minus 6 between parentheses multiplied by negative 1, because this is the axis of symmetry, plus 4. Let's calculate. Negative 4 by 1 by minus 1 square is a negative 3 by multiplied by 1, because minus 1 squared is 1, minus 3 plus 6, minus 3 plus 6, it will be 3 plus 4, it will be 7. So this quadratic equation has a maximum at the point, or the minimum located at the point minus 1, and we told 7. Okay, so here find the coordinates of the vertex. Now turning point, we see it is maximum or minimum. Since the equation of the axis of symmetry is x equal negative 1, and the vertex lies on the axis, the x coordinate for this vertex is minus 1. So you need, my learners, to find just the y value when x equal negative 1. Move to your original equation, y equal negative 3x squared minus 6x plus 4. This is the original equation. Just substitute x equal negative 1 in that original equation. You will get y equal negative 3 squared, negative 3 multiplied by minus 1 squared, this is a positive, minus 6 by minus 1, also this is positive, plus 4. So it will be y equal minus 3, yes, plus 6, because negative 1 by negative 6 will be 6, plus 4. Then you will simplify and add, you will get y equal 7. So the value of y, the y value of the turning point is 7 when x equal negative 1. So the vertex at the end you can be written as minus 1, 7, which is the let's say the maximum, because a is negative, a equal negative 3 is negative. Identify the vertex as a maximum or a minimum here. You will just say this one, minus 3 is negative, so your vertex should be maximum. Since the coefficient of x squared term is negative, the parabola opens downwards, and the vertex is a maximum point. Clear? Okay, the next part, we on the same question as we will try to graph this quadratic equation, y equal negative 3x squared minus 6x plus 4. Okay, this is the original. Now you can use the symmetry of the parabola to help you draw its graph on a coordinate plane. This is the coordinate plane. Graph the vertex and the axis of symmetry. Okay, choose a value for x other than minus 1. For example, choose 1 and find the y coordinates that satisfy the equation, or just try to construct a table of values for y and plot the points and join them together to get your curve here like that. So y equal, this is the original equation. Now x equal 1, negative 3 multiplied by 1 squared is negative 3 minus 6, negative 9 plus 4 gives negative 5. So graph 1 negative 5, 1 negative 5, what is this? Is Malern's 0, this is negative 1. Okay, this one, wait, this is, okay, this is the y-axis, this is 0. So we want to, let's say this is the axis of symmetry told. Okay, then we saw the axis of symmetry, we saw it here before. Okay, axis of symmetry, here we mean here is minus 1. That's why it's drawn here by a dashed pink dashed line. This is x equal negative 1. Okay, this point, the vertex or the maximum, and the curve is open downwards. So graph, okay, since the graph is symmetrical about its axis of symmetry x negative 1, you can find another point on the other side of the axis of symmetry, the point at 1 negative 5. Okay, it will be 1 negative, it will be negative 3 negative 5, and then you can sketch your parabola. Here we have an exercise. Which of the graph of y plus 1 equal x plus 1 all squared? Okay, let's focus this one. My learners here. Okay, so the equation is what? Our equation is what? Is y equal is y equal what? Y is equal between parentheses x plus 1, close the parentheses, then this one y plus 1, try to minus here, subtract 1 here from both sides, it will be here minus 1. Clear? Equal 0. Here, my learners, you can find, of course, here y is equal to 0, so the x-intercept will be, let's say, x plus 1 equal 1, or x plus 1 equal 1, or x plus 1 equal, okay, equal minus 1. Okay, so x equals 0 and x, so the first root x equals 0 or x equal negative 2. So this is the two roots, my learners, this is the two roots of my quadratic equation, this one. Okay, so which one, let's say, best describe the curve or the parabola? Look here, this one, this is the axis, the axis of symmetry, this is the x-axis, this is the y-axis. You can see the curve has a vertex at this point which is never touched the x-axis, so this one has no roots. This one has two roots. Okay, has two roots. Okay, again, I'm still recording the lecture. So here, this one has two roots, which is 0 and 2, but here we told 0 and negative 2. And this one has no roots because it does not catch the x-axis. But look here, this one, let's say it's a valley, it's a valley, it's an open, let's say, upwards, and this one, the x equal minus 1, the axis of symmetry. This is the axis of symmetry. I will label just it here, you can see it. This is the axis of symmetry, x equal negative 1. Okay, and this point has a minimum at what? At negative 1 minus 1, negative 1 minus 1, correct? So this one, let's say, best fit your equation. Okay, so here I will use insertion. Okay, and then I will use, let's say, this symbol or this one. Okay, which one, my learners, which one? Okay, I will use this. Okay, this one. So it has two roots, so this equation is that, the graph of it. Okay, clear? Or I will put it. Okay, then we move to the second part. So question another question, which is the graph of y when y equal negative 1 over 2 squared plus 1. See first the coefficient is positive or negative, the x squared coefficient or the coefficient of x squared, the x squared term or the coefficient of x squared. It will be negative 1 over 2. So the curve should be, let's say, open downwards and has a maximum. Okay, so here this is open upwards, so this one, no, don't use this one. Okay, so okay, so this one I will make like that. I will make, okay, so the first one is false. Okay, this is x. Okay, this one is not true. Why? Why, my learners? Simply because this is an open upwards and the coefficient here, so the coefficient, this coefficient negative 1 over 2 is is negative, so this is, you can't use this. And also the second one is open, let's say upwards, so this one is false. Okay, then here this is, yes, this is open downwards and this one open downwards, but we will see which one best describe this equation. Okay, we told before. So now we will make what, the axis of symmetry here, axis of symmetry x equals 0, and the vertex of coordinates, sorry, so the vertex here, it will be 0 0 1. Okay, and the axis of symmetry is 0. Okay, then it's easy now. So which one present, let's say, the graph of this equation? X equals 0, this is x equals 0, this is also x equals 0, but the vertex is 0 1. The vertex here is 0, x equals 0, this is 1, so B is the correct answer. Okay, so B, my learners, is the correct answer. Clear? I will just make this one here, copy. Okay, I will put it here. Okay, this is false and this is false, so the correct answer is that. Okay, is B. Okay, the next part. Okay, here the question is which equation corresponding to the graph at the right. Okay, we have what, this is an equation. The first equation is what, is x squared negative 4x plus 5, so the axis of symmetry here is 2. Okay, I will just make here for the first one, okay, for the first one, for capital A, axis of symmetry x equal what, equal 2. Okay, then for B it will be okay, minus 4, also x equal 2, minus, it will be minus 4 it will be minus 4 divided by minus 2, it will be 2. The second one, it will be x equal 2 also. The third one is the same, minus 4, yes, x equal 2. So all of these equations have the same axis of symmetry. Then we move to the second part. So look at the graph here. The graph, this is x-axis, this is x-axis, the y-axis, this is x-axis. So the axis of symmetry, x equal to, correct. And the turning point is one what? The turning point is what? The turning point which is v, has coordinates of what here? Of 1 2 1 2 1. Okay, in order to check, this is what we are looking for. This one learns is the keywords, because all of the equations have the same let's say the same what? The same axis of symmetry. We'll try to guess when x equal to, is it 1 or not. Here, the first one, x equal, I will use this one. So okay, here I will make instruction like that, or I will use this one. I will use an x here if we did it before. Yes, this one, copy, then we are here now. So then we told that I will add here something. Okay, x squared conception, move to x squared. Okay, this is x squared. Okay, x squared minus 4x plus 5. This is y, of course. Okay, this is y. We'll check if y, when x equal 2, will get 1 or not. Here, 2 squared minus, it will be 2 squared equal, when x equal 2, it will be 2 squared, it will be 4, minus 4 multiplied by 2 is 8, plus 5. So 4 plus 5 is 9. 9 minus 8 is equal to 1. Okay, this is correct. Now, if it will be minus 1, all the other answers will be not true. Okay, clear? And also the roots of this equation is what? You can find 2 square. Okay, 2 square. You can make like that. X squared will be, I will just put this, or I will do it like that. Sorry. The roots now, the roots are x-intercept, between parentheses, x-intercept, when the curve cuts the x-axis, means here y equals 0, of course, by the into parentheses, y equal 0. Okay, so we'll do what exactly? I will make x squared, I will make like that. I will make y equal, y of course here equals 0, so I will no need to write it. I will just write this one. So this is negative 4. I will divide negative 4 by 2. Negative 4, it will be 2. Then I will, okay, minus 2 squared is 4, plus 5. Okay, plus 5 equal 0. Okay, it will be x squared minus 2 this imply or gives this imply minus plus 1 equal 0, plus 1 equal 0. This one has no roots. Okay, let's check the second one. We told x squared, and let's see the curve has roots or not. Yes, this curve has no roots, so it's correct. Okay, look here, this curve does not cut the y-axis, the x-axis, so has no roots. So the first one, A, let's say match your what you are looking for. Okay, So the question is A. I will write here A. This is the correct answer. Capital A mean capital A. This is the correct answer. Okay. Now the second part. The second part, which graph does not represent a quadratic equation? Okay. So we can now cancel this one. Okay. Oh, no problem. I'll put it somewhere. Maybe the student will need it or something like that. Okay. We hope so. That is it clear? Don't know. Rotation, can I rotate it? No. Okay, no problem. I will put it here. But I'm going to make smaller. Than I will make 10. Okay, it's better. 16, 18. Okay, good. This one has no roots. Has no real roots. Why? Because the curve does not cut the x-axis. Clear? Okay. Now, which equation does not represent the quadratic function? This is a quadratic function. Why? Because the highest power is 2. This is also the highest power. The exponent is 2. This is the highest power is 2. But this one is not. Y equal x plus 1 is not the highest. The highest power is 1. So it's a linear equation. So this one is not correct. D does not match a quadratic function. Clear? The second part, here use the graph to represent which graph represents a function whose corresponding quadratic equation has no solution. No solution means what, my learners? Means that the x-intercept or the roots are not real. Means the curve will never cut the x-axis. Okay, so this one cut the x-axis at the point 0, 0. Here double 0. Here this curve is, let's say this is upwards, this is downwards. So this one has a maximum at negative 2, 0, double root. This is negative 2 is double root. Here upwards has two roots, x equal 1 and x equal minus 2. Then here you see this is the x-axis. Okay, and this one is the y-axis. So this one has no real numbers, no real roots. So the example is example C. Okay. So we told that C is the correct. Okay, 18, no, not 66. Okay, so we told C. Not this one. See here, I mean. My God, what happened? So this is C. Okay, the correct answer is that. Okay, this is the correct answer. For the second question, what are the roots of the quadratic equation whose related function is graphed at the right? This is the graph of the equation. We want to find the roots. Look, this quadratic equation or the graph, the parabola cuts the y-axis into 2 points, 0, 1, 2. This is x equal 2 and x equal minus 2. So the first one. Okay, copy and V, which is here, which is A, the correct answer. Okay, so thank you for listening. Thank you for listening, my learners. Inshallah, we'll, let's say, start doing the second lecture within 2 minutes. Okay, 28-29 March 2021. thank you for listening. Okay.